and this is part of the Guam and CNMI Water Operator Certification Series. This is a bi-weekly series. This is the third course in the water track, and I'm really excited to see you all today. Thanks for dropping that in the chat, Paul. It's always good to see who's in the room. I appreciate y'all introducing yourselves from Saipan. That's awesome. And so this webinar today is going to be essentially the same information as the basic water math class I gave yesterday. So if you were at the webinar yesterday as part of the wastewater track in this series, this is going to sound really familiar. It's going to be pretty much the same information. So just bear that in mind. I'll get into a little bit more about, why that might be as we talk about math and how it applies to water operators, but just know that going into this, it's going to be pretty much the same presentation as yesterday. So if you want more practice, you're going to get it. Hopefully you all came prepared today to start thinking about and doing a little bit of math. So I'm Shannon Pepper. I am a water utility trainer and specialist with the Southwest Environmental Finance Center. My email is on the screen here, and I'll show this again at the end of the presentation, but just know that I've got a door if there's anything you want to know. The Finance
Hey,
Center, which is
Shannon,
housed in the UNM University of New Mexico. Yes.
it's starting to cut out a lot
What's
on
up,
my end.
Andrew?
I'm not sure if it's the same for everybody else, but it's starting to get pretty
Okay.
choppy.
Okay, got you. All right, everybody. I'm gonna go ahead and turn off videos for everyone, just to help us with the streaming a little bit, so that we can keep the sound intact. And I think it's Squam Waterworks down there. If you could just turn your videos off, that would be awesome. And that will hopefully help us a little bit with our streaming quality. Great. Okay. So Southwest Environmental Finance Center is hosted at the UNM School of Engineering. And this whole training series is funded by the US EPA. So just a little bit of information about Zoom. Probably this will be review for a lot of you. Your control bar for Zoom is on a horizontal bar on either the top or the bottom of your screen. You've got a mute and unmute button at the bottom left there. That's really good. So if you want to unmute and say something, you're welcome to. Just got to hit that button first, and then please make sure that you remute yourself in case there's any background noise that the Zoom will pick up. There's also a start and stop video. Because of the quality of my internet, I think it is today, I'm going to go ahead and have everybody's videos off for this one just to preserve the sound quality. And then there's a few more important icons there. You've also got the chat. I might ask you hit that chat button sometimes and pop in on a question on the during the training today. WPI, ABC, operator certification. We try to cover the need to know criteria for water treatment operator 1 and 2. We might end up branching beyond those two levels, but for the most part, we're focusing on those basic 1 and 2 levels for these courses. Here's our schedule for the water track for 2025. Today we're on the third course out of 26, I believe it is, classes. This is basic operator math. The next class in this course is going to be applied operator math. So we're going to be investigating areas, volume, potentially getting into flow rates and detention time, and pressure if we have time for that. So keep an eye out for that one as well. It'll build off of what we're doing today. And this is the website where we host all of our recorded trainings. This is on our Southwest EFC website. So if you go to this address that you see on the screen here, you'll be able to access all of the previous trainings and recordings if you want to either attend if you missed one or review anything that we went over today. And do make sure that you sign in for all of these sessions and each session individually to ensure that you get credit for attending. The facilitator in your location will be managing the attendance sheet, so do make sure that you fill that out so we can get credit for you for attending. Okay. So why is it important to have a good understanding of math as a water operator? Math is really in everything that you all do. It's in water usage, in storage capacity, in determining flow and retention rates and detention rates for water, in chemical usage and dosing. And it's also on the managerial side of things really heavily, particularly in rate setting and budgeting. So it's really important. In order to get a basic foundation, we're going to go over some math fundamentals. And I don't know how you all feel about math, but I think math is pretty fun and it's kind of like a big puzzle to me. So you might also appreciate it. So let's get into it. Topics for today, we're going to be going over equations. So looking at order of operations, how do you kind of tackle equations one by one? And then how do you rearrange equations and solve for the unknowns? So that's kind of where the applied math comes in. We're going to be using math to try to find the answer to something, to some unknown question that we're trying to figure out. And that's also known as algebra, rearranging equations and solving for those unknowns. We're also going to go over percentages, units, and also units and conversions as well. So that's going to be our topics for today. This should provide a really nice base for you to kind of launch off from and tackle some more advanced math concepts later on. So I would also just like to get, if everyone could pull up your chat, if you have access to it, that's that little box with a dot with three dots in it on that horizontal bar. If you could pull up the chat and just maybe give me on a scale of 1 to 5, so some number between 1 and 5. 1, you're like, I'm just kind of in the really basic realm of my math understanding. I'm like maybe counting on my fingers, so that's a 1. 2, I am really comfortable and proficient in math. I'm like doing calculus on a regular basis. That would be a 5. So within that, between 1 and 5, what would you say is your comfort and proficiency with math? Just so that I have some idea of where we're starting for today. Cool. Got a 1. Awesome. 3 or 4. Great. 3. Awesome. Okay. Great. Great, great, great. Awesome. So we've got a really broad range of sort of comfort levels and understanding of math. And that's really great. And that we're going to just make sure today that we all kind of start off on the same page with some concept of the basic ideas of math that we'll need to grasp as water operators. So I really appreciate you all jumping in there and participating. So what is an equation? An equation is just really a technique for answering some kind of question about how much of something you have, how long something is going to take, how fast it's moving. And that's at the base, that's really what it is. And if we think about math as a language with numbers being symbols for some kind of idea or concept that we're trying to solve for, then an equation is like a sentence, and it's a balanced sentence. So whenever you see those two bars, one on top of the other, that's an equal sign. The left side is always going to equal the right side. So that little equals just means this thing over here is the same in quantity or mostly as the thing on the right side. So that's something to keep in mind as we're going forward here. And in these balanced math sentences, there's an order of operations that we really have to follow if we want to get the answer that we're looking for. And that order of operations has this really nice little mnemonic or like rhyme device to remember what order you want to do things in an equation. So that order is PEM, PEM, DAS, PEMDAS, and that You could remember it as please excuse my dear Aunt Sally. It's the one I learned it as. You could make it anything you want, but that one is pretty commonly used. So when we're moving through an equation, we first tackle parentheses. Then we look for any exponents that might be there, and we'll go over what exponents are as well. And then we're going to look at multiplication and division together. And if you don't see one, you just do the other and then move on to the next step. The next steps are addition and subtraction. So let's look at what that might look like in practice. So here's our example. Please excuse my dear Aunt Sally. We're going to try to tackle this equation using that order. So we see in this equation, then you're just going to treat that as multiplication. So we've got 4 times 2 plus, in parentheses, 6 times 5 to the second power, or squared, minus 16 equals what? So we're going to go through this equation in that order, starting with parentheses. So we've got 6 times 5 within those parentheses. So we're going to do that first. 6 times 5, we know it's 30. If we want to plug that into your calculator as well, that's great. So we have 4 times 2 plus 30 squared minus 16. So next, we're going to go ahead and do the 4 times 2. Or sorry, we're going to do the exponents. So we're on parentheses, we're going to move to exponents. We're going to do 30 squared. And 30 squared, another way of saying that is just 30 times 30. If this little 2 up in the upper right corner of the 30 said 3, then we would go 30 times 30 times 30. That's all that means. It's just shorthand. So if we go 30 times 30, we get 900. So we're going to now move on to multiplication, the M of the PEMDAS. So we've got multiplication, 4 times 2. We know that's 8, okay? Now we've got to divide. We don't have any division, so we're going to move on to the next ones. We have addition and subtraction. So now we can just take what's written here, plug that into the calculator, or do it in your head if you want, and that's going to give us an answer of 892. So if we go in at this equation in the wrong order, we might get a totally different answer, which is why it's important to remember this particular order of the PEMDAS when you're going through those equations. So for understanding these equations, again, as balanced math sentences where the left equals the right side, then we can also look at rearranging equations, which makes them a lot easier to handle before we insert the numbers, and also helps us keep track of the units. So we can kind of play around with these equations to serve us to answer the question that we're looking for. And solving for the unknown and rearranging equations is really also just known as algebra. So the unknown is the part of the equation that we're trying to find or solve for. And sometimes it's represented by a letter like D, T, or X. That's called a variable. And then when you're solving for an unknown, the variable or unknown has to be by itself on one side of the equation. That makes it really easy to figure out what that number is. If you have it by itself, then you just have your answer, right? X, or the unknown, is this number. So in this equation down here, 46 plus X equals 98. Let's look at what that might look like if we wanted to rearrange it to solve for the X. So to get X alone, to get it by itself, you just have to move the other numbers in the equation across the equal sign. Anything on this X side of the equation that we don't want, we're just going to scoot it over to the other side. But there are some rules about that. So because the equation has to be balanced, when one number crosses the equal sign, it's just going to do the opposite of whatever it was doing on that first side on the opposite side. So if a number is positive on one side, then you're going to be subtracting it from both sides of the equation. If a number is negative on one side, then you're going to be adding it to both sides. And what we're really doing here, so in this equation, 46 plus X is 98. We want to get that X by itself. 46 is a positive number. It doesn't have a negative sign in front of it. So we're going to be subtracting it from both sides. And when we subtract it from the left side of the equation here, it just basically cancels out because 46 minus 46 is 0. So that gives us an X just all alone by itself. And then all we have to do is solve the other side, which is 98 minus 46. And that will leave us with 52, an answer of X being 52. If you want to ever check your algebra, you can take your answer here at the bottom, x is 52, and just plug it right back into the top of the equation. So you could say, type into your calculator 46 plus 52, and you should get an answer of 98, and that tells you that you solved for x correctly. Here's another example down below with a negative. So x minus 12 equals 25. So in this example, the number that we're trying to get off the x side of the equation is 12, right? We want to isolate it, get it over to the other side of the equation. So we're going to have to add 12 to both sides because that 12 has a negative sign in front of it. So if we add 12, negative 12 plus 12, that gives us 0. So we've canceled out. Then we're left with the other side of the equation, which is 25 plus 12. And then if we just do it in our heads or punch it into the calculator, we're going to get x equals 37. And again, you can take that answer, that x equals 37, and just plug it right back into the equation if you want to check your answer and make sure that you did everything correctly. Always nice to check your work in this kind of circumstance, because sometimes we transfer the numbers wrong or write down something wrong, do it in our head wrong. It's good to check your answers. So at this point, I'm going to let everyone go ahead and give this a try. Since I can't see you, I don't know if you're doing it, so you're just going to have to take it upon yourselves to find a paper and a pencil or a pen, and work these out on your own. I'll walk through how to do it after, but it is really important for math to practice these concepts and actually write them down. Even if you're like a 5 on the comfort scale, you are super comfortable doing algebra and doing math. It would be really good to practice it because it's just good to make sure that you have those concepts really solid before we move on to the next level. So grab a paper, grab a pencil. If you don't have either of those things and you are in a room with other people, just chat with your neighbors about it. Talk through how you would solve this equation with each other, and that is also going to be really helpful in this process of learning and solidifying the concepts. So I'm going to give you, let's see, I'll give you 1 minute, maybe a little more than 1 minute to solve for x in these two equations. Cool. Thank you all for participating by dropping some of those. Know that you're working through those problems. It's really, really good. Okay. I think we're gonna call it there. So let's walk through these two equations. The first one, the one on the left side, let's look at how we get x by itself. So just remember that the rule that if we're trying to get x alone, then we're going to take all those numbers that are on the same side of the equation as the x, and we're just going to scoot them over to the other side of the equal sign. They're going to be doing the opposite of whatever they were doing on the x side. So for this one, if we were to just take this whole phrase, we've got 50 plus 8 on the right side. And then we're just going to go ahead and take this phrase, 2 plus 15 minus 8, and shift it over to the other side. But all these numbers, because we're just adding and subtracting, are just going to do the opposite of what they were doing with the x. So we've got 50 plus 8 minus 2 minus 15, 8. And if you just plug that right into your calculator or do it into your head, we've got x equals 49. That's going to be the answer for the first one. We want to go into the second one here. Really similar idea. But we've got a kind of tricky thing here, which is that there's a negative sign in front of the x. So let's first start by just getting the x alone. So we're going to take those 8 plus 6 and 5 plus 2, shift them over to the other side of the equation. And now we keep that 29, but then we go minus 8, minus 6, minus 5, minus 2. Because those numbers are doing the opposite of what they were doing on the left side of the equation. But that's fine. We can chug that into the calculator, but we have the problem of x is negative now. So what do we do? And this is kind of an advanced concept that we're going to get to in just the next level here. But basically, we can just multiply. We have a negative x and we want to know what the answer is. We can just multiply both sides by -1. Because what you don't see it here, but the 1 in front of the x is being very stealthy. It is there. And all we got to do is multiply both. And that leaves us with, if you go 8 times -1, that's going to give us a -8. It's doing the opposite of the x on this side. I'm gonna maybe take questions in just a little bit, but first let's go into multiplication and division since I kind of already got started on that. So to get x alone, again, same idea. Other numbers have to cross the equal sign, and the equation has to be balanced. So with multiplication and division, what is the opposite of what it was doing on the other side? Well, multiplication and division are kind of each other's opposites. So if a number is multiplied on one side, it'll be divided from both sides. And if a number is divided on one side for the x, it'll be multiplied on both sides. So in this example, we've got 5x equals 55. If we want to get that x by itself, since we're multiplying in our starting equation, we're going to divide both sides by 5 so we can get that x and isolate it by itself. If we do that, those two 5's on the left side cancel each other out, and we're left with 55 divided by 5, which is 11. So let's look at some more examples. We'll do a little multiplication and division practice here. So go ahead and I'll give you just under a minute. See if you can solve for x in this equation. So for this equation, I would probably start by, we've got these two numbers multiplied by each other on the bottom under that x. We're going to go ahead and multiply those together first to give ourselves one whole number to work with. That's going to make things a little easier. So if we do that, we got 41.7. 8.34 times 5, 41.7. To get that x alone, because we're dividing on this left side, the x is dividing this number, we're going to go ahead and multiply both sides by 41.7. So if we do that, it cancels on the left-hand side with the x, and then we get 15 times 41.7, 5.5. Okay, let's look at another one. So again, we're looking at if we're multiplying with the x, then what do we got to do to get the x alone? And I'll let you all go ahead and solve that on your own really quick. I'll give you about a minute. Nice. I love how active in the chat you all are. It's really nice to hear from everyone. Since I can't see you in this webinar, it's really nice to know that you're active and participating. Cool. Okay, let's take a look here. So in this equation, kind of similar to the one that I just showed on the left-hand side, it's going to help us a little bit to simplify this whole process if we go ahead and just multiply those two numbers together that we have that are both in parentheses. So we'll multiply that 7.2 times 8.34 just to start. And so then if we do that, we've got x times 60.048 equals 2,550. Okay, so now to get that x alone, since we're multiplying on the left side, we're going to go ahead and divide both sides by 60.048. So if we do that on the left-hand side, it cancels out. If we do that also on the right-hand side, we get 2,550 divided by 60.048, and that gives us an answer of x equals 42.47. So awesome job. Thanks for participating, everyone. And these formulas, you've got a formula and conversion table as part of your ABC exams. And I am really happy to drop this. If anyone doesn't have it already, I'm happy to drop this in the chat or email you a copy of this formula table. It's got all of the formulas that you'll need to know for the exam, and also a bunch of other useful information on it. And this concept of algebra where we're starting with an equation and then rearranging it to give us isolate the unknowns so that we can figure out the answer is something that you can do with any of the equations that you see here, to varying levels of complexity. So if you want to kind of practice this concept on your own, it would be a great idea and would also help you get familiar with the formula sheet and what it has on it, to just practice that with some of these different equations and use unknowns as unknowns and just keep them in their equation format and rearrange them, rewrite them. It's a really good way to practice some of this. And again, this formula sheet is going to be available to you on when you're taking the exam. So good to get familiar with it and what's on there for you. There's also this concept of pi wheels. So if you're not comfortable writing equations, this is another way you can do it. We don't have time to go really in depth into how to do pi wheels today. I'm totally happy to explain it to you. If you want to grab my email at the end of the presentation and shoot me an email about it, I'd be totally happy to walk you through it. But this is just kind of an alternative to solving equations that doesn't involve writing with that little equal sign. If you're more comfortable doing it this way, you get a couple pi wheels to reference on this exam sheet as well. So let's get into a little bit about fractions and decimals. Fractions and decimals are just used to represent parts of a whole. So if we want to work with both fractions and decimals, which we do on a daily basis, all you have to do to move from a fraction to a decimal is to divide the numerator by the denominator. The numerator top number and the denominator the bottom number, and they're separated by that little horizontal bar. So in this example, 1 divided by 2, and that is a fraction. So it's represented by 1 divided by 2. If we want to see that as a decimal, all we do is type that into our calculator or in our heads. 1 divided by 2. What's that? It's 0.5. So that's another way to represent that fraction. And then we have decimals to fraction. I would say it's you probably will do this a little bit less than going from fractions to decimals. So don't fret too much if this concept is kind of hard to understand. But basically, if you want to go from a decimal to a fraction, you first write the decimal as a fraction and multiply both the top and the bottom of that fraction by 100. And then you simplify using the lowest common denominator between those two numbers. So in this case, we have 2.75. And another way to show that as a fraction, you can show any number as a fraction by just putting it over 1 to begin with, because anything divided by 1 is itself. So in this case, we can go 2.75 divided by 1, and then we can multiply both the top and the bottom by 100, which gives us 275 divided by 100. And then if we think about it, we can say, okay, what's a factor that both of these numbers have in common? Both of these numbers can be evenly divided by 25. So we're going to go ahead and divide 25 on the top and 25 on the bottom, and then the lowest fraction between these two. And so that's going to give us our final fraction, which is 11 over 4, or 11/4. That's another way to say that. And then if we think about percentages, they're really just another fraction. What that little percent sign means is that it's parts per 100. So fractions, these are all fractions with 100 in the denominator, or the bottom number. And they can all be converted to either a fraction or a decimal. So if we start with 30%, that's 30%, or 30 parts per 100. So you could write that as 30 over 100. You could also write it, if you were to type into your calculator 30 divided by 100, that'll give you a decimal of 0.3. So all of those are the ways that you percentage. And then we can talk a little bit about converting percents to decimals. So to convert a percent to a decimal, there's a couple of different ways we can do it. So first of all, we're going to drop the percent sign because we're going to stop talking about it in terms of percent or per 100. Then we're going to divide that number by 100. And if we were to just put into our calculator 65 divided by 100, we're going to get 0.65. Another kind of quicker way to do it, if you don't want to plug that into your calculator every time, is just to scoot your decimal place over to the left 2 places. Um, and so that's kind of a shorthand. So point, or sorry, 65%, the whole number 65, you've got a little invisible decimal after the 5. So if you, another way to write this could be 65.0. So if we want to change it to a decimal and drop that percent sign, all we got to do is take that in the little decimal after the 5, 2 pieces, basically. And that'll give us the same results. So it's a little bit faster. And with decimals to percents, it's really the same. It's just the opposite. So we're starting with a decimal and we want to show it as a percent. All we got to do is take that first decimal, that fraction, and multiply it by 100. And then that's going to give us 65. And then we want to make sure that we plop that little percent sign after it because that's what shows that it's a percent, that we're represent the number as a percent. And if we want to do it the kind of shorthand way by not plugging it into our calculator, we can just take that decimal that's to the left of the 6 and move it over the other direction. So to the right 2 places. And that's going to give us the same answer. We just want to make sure that we put that percent in there to show that we're representing this number as a percent. Hopefully that'll make sense. If you've got any questions about anything, any of this that we just went over, please feel free to drop it into the chat anytime and I can address those questions as we go. But first, let's get a little bit of practice in this changing between decimals and percents. And again, if you've got any questions, feel free to drop it in a chat. But I'll give you all, let's say, 2 minutes to work through each of these, either by yourself or with the people next to you, and then we'll go over all of them together. Okay, so let's see how we did here. Thanks everyone for participating in the chat. So we want to change the percents to decimals. Just remember that we're starting with the 3%. If we want to show it as a decimal, 100, put that in the calculator, see what we get. You could also take, there's like a little invisible decimal after the 3 and just scoot it to the left to scoot it back 2 places, and then show that number there. So for this, we've got, that gives us an answer of 0.3 for the 3%. If we want to do that for 25, same deal. We could divide 25 by 100, or we could just scoot that decimal place over 2 places, and then that'll give us 0.25. For 0.05, we've got a lot of zeros, so we're gonna take that decimal, we're gonna move it 1 0, 2 zeros, and that gives us 3 zeros before that 5. If we want to do 135%, we just take that little decimal place, the little decimal after the 5, and move it to the left 2 places, and that leaves us with 1.35. And we want to make sure we're dropping the percent on those answers. If we want to go from decimals to percents, just go in the opposite way. So we multiply 10.5 times 100. That would give us 1,050. We multiplied 0.01 times 100. That gives us 1%, little decimal, and scoot it over 2 places to the right, and that gives us 36%. And same for this bottom one. If we take that decimal, scoot it 2 places over to the right, we're going to have 26.3%. Okay. So let's also talk a little bit about rounding. And we have a little story problem here to work with. So in the story problem, the temperature of a digester that operates in the mesophilic range is measured to be 37 degrees Celsius. So what is that temperature in degrees Fahrenheit? So if we have a story problem like this, that question at the end is going to be asking for what we're trying to get here. We're trying to get 37 degrees, but represented as Fahrenheit, degrees Fahrenheit. So if we look at our exam cheat sheet, we've got an equation for degrees Fahrenheit. And that equation is degrees Fahrenheit equals degrees Celsius, so whatever number you have for that, times 1.8 plus 32. So all we got to do is take that known, so the 37 degrees Celsius, plug it in for that degree Celsius in the equation, and that leaves us with 37 times 1.8 plus 32. If we're doing our PEMDAS correctly, remember, we're going to first multiply, right? Before we do any addition or subtraction. So let's multiply those numbers. We get 66.6 plus 32, and that gives us an answer of 98.6 degrees Fahrenheit. But wait, none of the numbers that we have as our answer options on the left here are 98.6. What do? We round. So rounding is just really kind of like taking a number that is not a whole number and approximating it to the next highest thing. It just simplifies the numbers that we have to keep track of so that if we get some kind of big number, we know how to kind of reduce it down to the closest approximation that we need for our purposes. So in this case, we've got 98.6. And so if we're going to round up, we'll round up if the last digit is between 5 and 9 on the numeric scale. And we'll round down if the last digit is between 1 and 4. And in this case, it's the last digit, but if you had a number that was really long, like 98.651234, whatever, you're just going to pick the last number that you want to round to. And so if we wanted to go 98.6, then we're going to look at the next number in the equation. Is it between 5 and 9 or 1 and 4? If it's between 5 and 9, we're going to round up to the next number for our final number. If it's between 1 and 4, we'll round down. So in this case, 0.6 is between 5 and 9. So we're going to just go ahead and round up to the next whole number, which is 99. And that is one of our numeric answers here. And this, because on the exams you'll have these number options here, they're not going to be too tricky about it or too strict, I think, usually about rounding, but it can help you when you're doing your equations to keep track of those numbers. If you get a big unruly number for one part of your calculation, it's really helpful to know like kind of where you should be rounding to as you do those equations, and that will give you the closest and best answer for what the exam's asking for. So that makes sense. Let's talk a little about units too. So we just went over a couple of units, degrees Celsius and degrees Fahrenheit. Units are just a way to track what you're measuring with your numbers. So when we do this applied math as water operators, it's super, super important to keep track of your units so that you know what those numbers represent. They're not really useful to you at all unless you know what they represent. So for temperature, some units that we often work with are degrees Fahrenheit, degrees Celsius. That K stands for Kelvin. For units of distance or length, we often work with inches, with feet, with meters, miles, kilometers. All of those things measure distance. For area, we know, we'll get into area and volume a lot more in the next training. But basically, because we're multiplying the length times the width, we end up with that little 2, that little exponent 2. So if you see inches squared, feet squared, etc., you're talking about area. For volume, because you're adding another dimension, you're adding not just length and width, but also depth, then you are going to have that little 3, and that tells you that you're working with volume. Gallons and liters and acre feet are other common ways that we represent volume. And then for mass, we have pounds, grams, kilograms, and tons. So how much does something weigh? And for rate, we're sometimes looking at cubic feet per second, like how fast is water moving. We might also be looking at gallons per minute. And just a quick little question here for you all, if you want to shoot it in the chat. Rate measurements are a unit, so volume or distance, divided by what other variable or dimension? What do you think? Is it height, weight, time, or volume for rate measurements? Yeah, thanks, guys. So yeah, it's C. It's time. Rate is always a representation of some kind of unit like volume or distance over time. And that's how we know that it's a rate or considered to be a rate. Awesome. So in the US and US territories, we are blessed with a mix of metric and imperial system measurements. So metric system is pretty cool. It's very logical. You have your kind of base measurement. In this case, we have a meter, a liter, and a gram. And then if you want to represent different amounts or portions of that base measurement, then we have the number, the word that comes before it. So like for example, centimeter, very great because centa means 100. So we know that means 100 centimeters in 1 meter. For milli, whenever you see milli, that means it's a thousandth. So 1,000 millimeters for 1 meter, and so on and so forth for volume, for liter and grams as well. And so that's really helpful. We don't use all of these, right? Like deca, hecto. We don't use kilo for everything. We don't use centiliters. But the ones that you see that aren't crossed out here are all really commonly used. And so that can be helpful to remember if you need to convert between a milligram and a gram, or show a milligram as a gram in an equation to make the equation work. Just remember that you can use those, you can use what's in the word to help you figure out how much to represent it as. So, and what we're talking about here is conversion. So there are also a lot of other kind of conversion factors, we call them, that you can use to figure out how to represent one measurement as a different kind of measurement. So with acres, we're working on area, right? So it's an amount of space. And we can also represent that as square footage. Um, for example, when we have like a rate, like 1 CFS, we can also represent that in gallons per day or million gallons per day. Um, and so on and so forth. And these conversion factors are all listed in your exam, your ABC formula sheet. So that's really helpful. If you find yourself in an equation and you're like, okay, the, I have some number that's representing volume, but it doesn't quite fit into the equation that I have, which calls for another kind of volume. Can I convert that number to get to where I need to go and put it into the equation and make it work? So that's what these conversion factors are really, really helpful for. And you'll use that a lot, especially in this exam and then also just in your day-to-day. So that's very helpful to have. So let's dive into conversion factors. This is going to be a really brief overview of conversion factors. We'll definitely go way more in depth in in the next course. And then if we have more math as part of your this webinar series, conversions will certainly come up. So how do we use those conversion factors? We want to multiply or divide the measurement that you have or that you're given by the conversion factor. So what you're really doing here is turning the conversion factor into a fraction and then multiplying by 1. And kind of playing around using that algebra, those rules of algebra, to get rid of the factors in the equation that aren't useful to you and leave you with the one that you want. So what that means, for example, we're looking at 1 gallon equals 3.79 liters, for example. So this is what we call a conversion factor. We know that in 1 gallon, there are 3.79 liters. And we can represent that in terms of showing that 1 gallon over 3.79 liters is equal to 1, and then 3.79 liters over 1 gallon, also 1. Let's look at that in practice a little bit as well, because I think it makes a lot more sense when you kind of just see it done. The idea is that you can multiply anything by 1 and not change its quantity and just change the units. So here's an example of unit conversion. Your tank holds 40 gallons. What's the question really asking? It's just asking to show your tank capacity, which is currently in the problem we have it as gallons, but we need to know how many liters we need. So we need to show that number in liters. So how are we going to do that? We're going to use conversion factors. We have that conversion factor that we saw, 1 gallon equals 3.79 liters. And what we're going to do is over 1 for your gallon. And what this does is basically cancels out those 2 gallons because you've got a gallon on the top and a gallon on the bottom, so they cancel out. And you're left with to go 40 times 3.79 liters. I personally find it a lot easier to do these problems because it can get a little messy what's on the top for me. So I like to write these conversions out in a grid, and it works kind of similarly. So here we're starting with 40 gallons, and then we take our conversion factor where we've got a 40 on the 40 gallon top, 1 gallon on the bottom. We get to cancel out those gallons. And so that leaves us with just liters, which is great because that's what we're looking for in our answer, right? Is how many liters that will fit in that 40-gallon tank. And all we do is multiply across the top of the grid. So 40 times 3.79, again, gives us about 150 liters. And that 1 on the bottom, we don't have to worry about it because anything divided by 1 is just itself. So that's just a way to kind of hold the place and remind yourself of what numbers you're kind of working with given any given moment. So let's have all of you go ahead and practice this conjugate unit conversion and this on the exam. So to figure out the volume of your clarifier, you're going to measure it with your tape measure. And you determine 46 cubic feet of water. How many gallons do your clarifier hold? So with 46 cubic feet, and you're trying to figure out how many gallons equals 46 cubic. So go ahead and do that. I'll work that out together. And we'll come back and work through it. Okay, so unit conversion. Let's look at how many gallons the clarifier will hold if we know what the volume it can hold is in cubic feet. So let's see about gallons. So for this one, since our conversion factor is for every cubic feet, that's what we're given, and we can put 46 over 1 and factor on the hands of the grid, and we're going to 7 the equation, which is awesome. That's where we want them so that we can cancel them right out. And now all we got to do to get on top of the grid times 7 gives us an answer of 344 gallons. So that one, if it didn't, don't worry. What I found is one of the hardest concepts and also one of the most important concepts, I think, probably for your exams. So if you need more practice, let me know. I have a bunch of practice problems. Would be happy to share them with you if you want more opportunities to practice this concept. We've got one final let's look at order of operations in a kind of more longer and more complex equation. So circling back around to that. Um, so to calculate your CT, which is part of what we would want to count to determine the volume of water after treatment and before your first customer, including water in the mains that have a 1 foot diameter and are 860 feet long, and a box-shaped storage tank. You determine the below equation for calculating that step, right? Pi, which is and it's a common number that is just used to represent the squared times 860 plus 20 times 15 times 25. So what we would do first is go ahead and do what's inside the parentheses, so 1 foot over 2. And then for the next step, we would want to move on to the exponents. And if we're just how we have unit here, all we have to do is put that little exponent after the unit, which is feet, 60, so on. And the next thing that we would want to tackle, that pi, that multiplication part of things, so pi times 0.25. And then you could also multiply those two things by the 860 feet. And if you do that, anytime you're multiplying a unit by another unit, you're just going to add, go one, we're starting to get 675 feet square or feet cubed. And then on the right hand side, same deal, because those units are multiplying by each other, then we just basically add the exponents together for each of those feet units. So if we do that, we finally got conglomerated all of our feet together in this equation. We've got 675 feet cubed plus 7,500 feet cubed, and that gives us 8,180 feet cubed. I'm sorry I didn't get a chance to let you all work through that on your own, but hopefully that gives you some sense of what you might do with units when you're working with units in order of operations together. So that's about all I've got for today. And I can stay behind for about 5 minutes and answer any questions. If anyone wants to stay behind and ask questions, I'll be here. And thank you all so much for attending. Please feel free to reach out to me at the email that you see on the screen here. If you have a question that you don't have time to ask today, feel free to send me an email and I'm happy to answer individually. The next webinar in the series is going to be Water Math Part 2, in which we'll go over area, volume, pressure, just a few more advanced concepts. And that will be in 2 weeks on August 6th. So I hope that you all are able to make it to that one. And thank you so much for taking time out of your days to come and do some math with me this morning. Again, I'll be around for a few minutes if you all would like to stick around and ask any questions. Thanks so much, everyone. Okay, somebody asked where they can get a copy of the PowerPoint. So these presentations are all going to be posted online. So I can go ahead and drop that website in the chat if you all would like. All right. So at the website that I just dropped in the chat there, you should be able to visit any previous trainings. And Andrew, do you know if PowerPoints are also going to be posted to that same website where we have the recordings hosted?
Yes, the PowerPoints will be right there next to the recording links. And the team's trying to get those on there by the end of the week that we do the recording. So hopefully or by Friday, Monday, you'll start seeing those show up after the trainings.
Okay, awesome. I'm not seeing any more questions, so thanks everyone for sticking around and thanks for bearing with me in the sound delays. Really appreciate it and hope to see you at the next one. Let me know if you've got any questions in the meantime and hoping to see you there.